Hello. In this video, I want to talk about data on the web, routing, and how those two concepts are connected. So first, let's open a web browser and look at some common websites. So here's Wikipedia, and you see in the browser bar we're at en.wikipedia.org. So supposedly this subdomain en is probably, English subdomain of Wikipedia. For wiki articles, we're under the wiki path, wiki articles, and we have this ID of Abraham_Lincoln. So that's probably the unique ID that identifies this wiki article as opposed to, say, President of the United States wiki article. So when we go to a particular hash on this page, hash is the symbol used for IDs in web document query selectors, and also when we use those in a browser bar, the typical behavior is to take us to the element with that ID. So if we look here and hover over family and childhood, you'll see it's a H2 with family and childhood as the ID. And so that's a way that we can skip a bunch of content and go down to a specific area on a page. And this link is portable, so we could share this with somebody else and take them straight to the part of an article that we are interested in reading, for example. Now let's look at Google Scholar, where we're searching for articles about a heart condition. So you'll see there's all kinds of information past scholar.google.com. You see we're on the Scholar app. That's the path that they've chosen to put this under. And we have some query parameters. So there's a question mark that specifies the query parameters are starting. And then there's a bunch of ampersands that join the different query parameters. And then each query parameter has a key, a name, like HL, and a value, like EN. So HL equals EN probably means something about, maybe the language is English, and that's a query parameter here. Or we have this Q, which is a common query parameter to use for a query, a search query. So we're asking about atrial fibrillation, so we have atrial plus fibrillation in the URL. And that way we can copy this and we can share it with somebody else and show them our exact search. So rather than having this search empty and just having them land here, they actually land to the exact search that we typed in just based on that URL alone, because the website can handle that. Now let's look at a music app. We have this album on Spotify somebody recently shared with me, and we can see each of the tracks. When you hover over it, when you hover over the track, you see in the lower left a URL, open.spotify.com/track/ and then an ID number. So that's the way that they're organizing. Each track is a data item, and each track has its own ID. If I hover over the artist, you'll see the website /artist/ID, and that ID is going to be the same for all these links that go to the same thing. If I hover over, say, the album itself, like, let's see if we go back here and hover over this album, you'll see that it's spotify.com/album/ID. So those are just ways to organize these different types of data. You have albums, you have tracks, you have artists, all these different kinds of pieces of data. Same thing on Amazon. If you go to look at a certain type of product on Amazon, you're going to see all these different things come together. A list of data items, so for example products, and then each product has its own link, and it has some ID that identifies it. So here /s, maybe that means store, the Amazon store, and then a bunch of query parameters that are a bunch of data that Amazon likes to store in the URL. And if we click on a particular item, $140 beanie, then we can see that that's identified by, first and foremost, its ID here. And so that's how one of the ways that Amazon can identify this particular page on the website. And if we go to for example, fashion, we go to /Amazon fashion. So they've organized all the content under there into this. Or we go to today's deals, that brings us to /events/big spring sale. So just different ways of organizing those pages. Same thing on YouTube happens. When we click on a video, we go to youtube.com/watch.
Hello everyone.
And then we have a video specified by ID in the query parameters in this case. So it says $v equals and then an ID number. So that ID number can identify this video uniquely. Same thing would happen for playlists. Playlists would be identified by sort of playlist type of identifier. Like if we go to one of these playlists here, hello, and you'll see that if you click on the playlist and try to visit it in this video, you'll see in the URL bar we have /playlist $list equals and then some sort of ID number. And so each of these videos is a data item, and then it can belong to this playlist, but it can also belong to other playlists. Now, last example is Canvas. We have different places you can go on a particular Canvas site. So this is the learn.vccs.edu, but I could go to /profile/settings. I could go to the home page, which is called Dashboard. I could go to the calendar. I could go to my conversations. And then within a particular course, I'm in this course right here, that's identified by /courses/ID number. And then different things under there are, for example, /courses/ID number/announcements. So if I go to announcements and I hover over an announcement, you'll see that that is /courses/ID number/discussion topics/ID number. So it turns out announcements are just discussion topics. And so if I go to discussions, which is discussion topics, and hover over discussion, you'll see that's also a discussion topic. So somehow in the underlying data model for Canvas, they're representing announcements as discussions that are just, in a different section for the users. So all these different examples are just ways that you see data being represented and organized through this kind of file folder metaphor that we can understand. So this is like your typical file explorer here. If I go to my code folder on my file explorer on Windows, and I have a web folder, and then I have different folders and subfolders, up here in the browser bar of my file explorer, I have a file path. So those are nested files where it's hierarchical. And so typically the HTTP, the Hypertext Transfer Protocol that we use in web browsers to have these URL bars, is a similar type of concept where it mimics this idea of having files and folders. So you could think of github.com like a big hard drive, and then it has the path for this particular GitHub user, and it has a subpath of that, which is their Navigo GitHub repo, and then it has a tree subpath that has the different branch names. If we were to switch to different branches, you would see that that path would change, and that can change the content on the page. So we're just able to kind of use this file folder metaphor, even though we're not always necessarily representing things as files and folders. So to give you an example of what I mean, you're probably familiar at this point with the basic concept of a GitHub Pages site or a static website of some kind. So here I have a static website that I wrote, and inside of the docs folder I serve this at a particular place. So I serve this at nGardella CC front-end portfolio, and then all of these different places that you go, like the to-do list under demos, these are actually files and folders inside of my static site. So that if you click into this docs folder, you'll see there's an about folder and a demos folder. Inside the demos folder, there's a to-do, and then there's an index.html, and that's what's happening when you go to the to-do list, is this index gets registered. But you can actually sort of fake this by using program code to serve a static website, but then kind of fake what's in the URL bar to give the desired outcome without actually having to have those files on hand. So what's an example? Well, here is an app that I'm going to be showing you where it's essentially dynamic routing done in JavaScript. So if you look at the docs folder for this is the same basic concept as that other Pages site, except here all that gets built out is an index.html file and a 404.html file, which is the file that a lot of web servers will look for when they can't find the file that you're asking for. So by default, when I go to, for example, /navigo app/data rows, I have a bunch of ducks being rendered here. And you'll see that in the path, I'm asking for this app, which is at this subpath, and then slash data rows. You'll see that I have no file in my docs folder called data rows. I have no folder called data rows with an index in it. So the question is, how is anything happening here? Well, basically what I've done is I've tricked the server, the local server that's serving this, and it is actually returning 404 when it tries to get that content. You'd see that better if we went to the GitHub Pages deployment of this site. So if we go to the home page, and then we go in the network tab and reload, everything comes in fine with a 304 or 200. And then when we go to data rows, you'll see a 404 happens, yet the content loads anyway. So the reason is that the GitHub Pages server is not finding the data rows file or folder, but then it says, okay, I'm going to return 404, but I'm going to also return the HTML, your custom HTML file for when errors happen. And I tricked it by giving it the same content in my index as my 404 so that it just renders my regular routing logic from my index, my single index, and which imports my JavaScript that does all of the routing programmatically. And so it's a way of tricking the static website hoster that I don't have control over into letting me have nice dynamic paths. And you might think, well, why do this? Why not just create all your paths and have files and folders so that you don't have to do this weird hacky thing? And basically the reason is because a lot of times you want to have dynamic paths available. So for example, if a user wants to look up a specific data row, I've done this all programmatically. These aren't actual data items in a database. I've just made up the numbers 1 through 10, and I've said what should happen when you go to a particular page, like data row 6. So I can't predict what the user's going to put in. They could put in 489, and it's going to show something dynamically based on what's in this URL. But I can't predict that there's going to be a file called 489.html all the way in this folder structure. So there's no choice except to handle that dynamically. And so it's a very important skill to learn at some point. Even though there are benefits to having static files and folders in your web server, it's a very important skill to be able to handle those dynamically as well. So let's talk just a little bit about basic data models, relational data models that kind of connect to the idea of having a database, like a SQL database, for example. So think of data, a particular type of data. So say your users or notes in a note-taking app. Each of those is a certain type of data. Like in YouTube, you had videos, or you had playlists, or you have users. In Amazon, you have products, or you have, you know, the store itself has lots of products in it. In Spotify, you have albums. That's one type of data. You have artists. That's another type. You have tracks. That's another type. And so think of each type of data as a table, and then each particular piece of data is a row in that table, like a spreadsheet. So here we have a table for users, and each row is a particular user. You can also represent relationships with rows in tables. So we have users here. Each row is a user. They have an ID number that is specific to the context of this table. So here ID means a user ID. Here in notes we have ID1 again, but now it's a notes ID because we're in the notes table. Now we can use the connections between two IDs to connect data rows in previous tables that we've considered into a new table. So here we have an ID that represents not a note, not a user, but a relationship between a note and a user. So here we're saying that note with ID 3 belongs to user, or sorry, this is a user sharing. So the relationship with ID 1 references the note with ID 3 and says that it should be shared with the user with ID 6. So if we look at the note with ID 3, that would be this, and the user has ID 1, which if we check users is Grace. But in that sharing table, the recipient of the sharing, obviously the user who made the note should be able to view it, but now they've shared it with recipient 6. And so recipient 6 in users is Uttar. So now that note is visible by not only Grace, but also Uttar. And you see, if we wanted to share the same thing with multiple people, or if we wanted to have one person create multiple notes. Like here, Grace has created the note with ID 2 and 3. They both have her user ID and their different content. We keep this in another table because if we put it here, then the number of columns we have would be unknown. It would just keep growing to the left, or we would have to put like an array of, for example, shared users. This would have to have, maybe 1, 3, 4, and this could just get really big and hard for the database system to actually efficiently look over. So the better way is to separate these things into tables that are as minimal and condensed as possible, and then connect those tables to each other using unique ID numbers. So we have unique ID numbers for notes, we have unique ID numbers for users, and for note sharing relationships, and so on and so forth. So that's essentially how most apps on the web today are working, even if they have multimedia content. Consider like a profile picture. You can simply represent the profile picture as zeros and ones, which you can encode as a string, like text, or you can have a string that represents a URL, and you go and fetch that file from a web server, because remember, web servers can serve files. So the web server has a file which is made up of zeros and ones, and you have a URL that links to it, and so you can basically retrieve that image content when you go to display it in the web browser if you have all the data in a particular row. Last thing to note is that you can think of each row as, if you know about like object-oriented programming, each row is like an instance of an object. So this table is like an object class, the user's class, and each row is an instance of that class. So for example, this is an instance where the name property is Grace. And so it's a good idea when you're, whoops, I accidentally clicked that link. It's a good idea when you're naming your columns to choose names that are friendly to URLs. So URLs like dashes, for example, rather than spaces. It just makes things cleaner and shorter. And even you might want to consider choosing something that's friendly for a variable name, like phone_number rather than phone-number, since a lot of languages won't let you use dashes in their variable names. So just kind of things to think ahead about putting your data in a database, working with it in program code, and so on and so forth, so that you have a good idea of how your data model connects to your browsing model. So finally, let's just look at the browsing model for this simple site that I'm faking these dynamic routes with. So it just has a single HTML file, and then I'll remind you this is the source code, not the bundle code. So the bundler actually produces this docs folder with a bunch of confusing JavaScript and CSS, but it's based on my source code. So my source code is just an index file, a main.js file, and a style file. So the index file brings in those two other files, and then I have a header with a page title that's empty, a nav that's empty, and some main content that is empty. Then in my JavaScript file, I essentially fill in all of that stuff based on whatever is supposed to be happening. So in the case of the home route, I fill in the empty string, meaning the base route, I set the title to home using this little utility function that changes the page title and also the tab title. So if we look at the website, you can see what that means. Essentially, like the tab right here is titled Navigo app pipe home, and so is the H1 at the top of the page. And then after that, it just sets the main content to contain this message. And if you're wondering how I'm doing this, there are two libraries I'm bringing in. Now, you could do all of this with plain HTML and JavaScript, but I'm using these libraries just to make things a little bit easier. So Navigo is a library for front-end routing that's pretty minimal, and jQuery is a really popular language library for editing the DOM. So you can do things rather than document.querySelector, you just use like $, for example, and it has all these methods that are slightly less text to get a desired outcome. So what I do is I create a Navigo router. I add a hook that just essentially says before you load every route, no matter what route we're on, before you load every route, I want you to add this nav content to the top so that I don't have to manually type it in 10 places. If you've ever done that before, you understand that that's pretty annoying. So now I have a data rows handler that takes you, when you click to data rows in the browser bar, it does this particular page. So it sets the title to data rows using that helper function. It makes some fake rows, so just the numbers from 1 to 10, and then it creates a table where each piece of the table, it has a link to that particular page. And once you click that particular page, then you could go to the dynamic route handler for, say, row with ID 4. So 4 is that ID there, and I've added a bunch of ducks here to the content just so that you can see the action of the hash in the URL. So I've said an href to hash, which means the current page with the hash table added to it, and that just says go to the element on the page with the ID table. So even though I have all of these ducks in the way, I can quickly have a link that says jump to table, or I can share this URL with somebody and they can paste it in their browser bar and be taken straight to this table content rather than having to scroll all the way past all the ducks. So I'll just quickly remove those, and you can just see the normal page it's supposed to be. And when you click on one of those, it dynamically handles this route because I have /data row /:ID. And :ID with different router brandings, there's Navigo that I'm using now. In React, you might see React Router. You might use the Next.js, might have routing techniques for their setup, but essentially this is a very common syntax to use where you have : and then the name of a particular parameter you want to pull outside of the query parameters. And so you also can have query parameters, like I hit show hide duck and you see $duck equals 1, 1 being true. So when there's no when this parameter is not there at all, or when it's set to 0, the duck is hidden, and when it's set to 1, the duck is visible. And so that way when I share that route, if this query parameter is set, it will take you straight to the correct view without having to click anything or interact. It can just go straight to the view that you want using the URL. So when we pull this ID out, that's how we're able to construct this dynamic title, even though there's no HTML file called 1.html. We can create this experience with dynamic routing programmatically. And so essentially it pulls that out of this parameter that Navigo will pass to our function that handles this route, and we just essentially pull out the ID, we set the title to have that ID, and we set the main content to have this paragraph that says, row P, this is the view for data row, whatever. Then as you've seen, we have the home handler that just shows this, and then star handler, which is the fallback. That's kind of like what GitHub has for the 404.html. This is essentially our 404 HTML. So if we type some path that doesn't exist, I have a handler that says cannot find whatever that path is that you asked for, and invites you to go home. And so it doesn't have some weird ugly view that looks nothing like the rest of the site. It's saying, I know that you were trying to find this. I'm telling you that I don't have a way to solve that, and so I'm inviting you to just go back to the regular flow of the website. And so you see it's quite simple to create all of this, and it's got this very nice ability to do different things, like adding a hash to go to a particular item. For example, when we passed all the ducks, when we have the particular data row, we can use a query parameter, for example, with to show or hide the duck, and then that's stateful inside of the URL, so that if we share this URL and it has that particular parameter in it, it can give us that behavior of showing or hiding the duck as soon as the user lands to the page. And then finally, the dynamic routing that you've seen, where even though we don't have 3.html or 665.html, we can create a dynamic route based on that content, which is really cool. Alright, so that pretty much covers everything, but finally I just want to emphasize that the way that this very simple site is laid out is, common for different websites, and you might want to consider using a simple pattern like this, where you have, for example, a /many things row, so products, with an S at the end, or songs with an S at the end, or photos with an S at the end. And then you might want to consider having subviews for a particular item that you would show in that view of everything. So you have a list view of all these things, or this is a table view, and then you go to a particular one. Now we have data row with no S, or we might have product with no S, or we might have song with no S, and then an ID number that identifies that song. Or in the case of Wikipedia, it had that Abraham_Lincoln that identified the wiki article. So using this very simple model is super common, and it just allows you to keep everything organized and use links to your advantage to kind of structure your website in a way that uses this file folder metaphor, even though there may or may not actually be files and folders under the hood. What matters is that the user can understand how to access different data in a way that makes sense to them, and this is a common way to do it. So I'm not going to get into how relational data would kind of be brought into this, or actually saving the data, but it's important that you can understand how you can use the routing and the URL bar as an important place to keep data about where you want to be on your site. That's essentially the point of the URL bar. And so if you can follow those kind of techniques, it's going to be much easier to keep everything straight in your head as a developer, but also for users to be able to navigate your site. So in a future video, I can show how to create something like this with dynamic routing, but here I hope that you can take away that there's a very straightforward connection between tables of data, relational data, and having rows within those tables that connects very closely to how routes are organized on websites. So thank you for watching, and I'll catch you in the next one.